This application problem from our second day of homework. We have a powder that's making cups and plates. Well, that's exciting. It takes her 6 minutes to make a cup and 3 minutes to make a plate. Now, when I have made cups or plates in pottery, it took me much longer than 6 minutes and 3 minutes, but whatever, this girl must be good. Now, each cup uses 1 pound of clay, and each plate uses 1 pound of clay. So they each use 1 pound. And she has 20 hours available for making the cups and plates and has 250 pounds of clay on hand. And she makes a profit of $2 on each cup and $1.50 on each plate. How many cups and how many plates should she make in order to maximize her profit? Okay, well, here's where it gets kind of difficult here. When we have a ton of stuff going on, it's hard to figure out your variables. But let me give you a tip. I think it's useful to start with our objective function. Our objective here is, it says, how many cups and how many plates should she make in order to maximize her profit? So profit is our objective here. And we're wondering how many cups and how many plates she should make in order to maximize it. Well, if she makes $2 per cup and $1.50 per plate, our variables we can see are going to be number of cups and number of plates. All right, number of cups, number of plates. Those are the variables we're going to be using here. Okay, so let's see here. Now we have our minutes, so we have our time, and it looks like we also have 20 hours. Let's work with that right now. Well, if I did 6C, because 6 minutes per cup, plus 3P, because it's 3 minutes per plate, and she only has 20 hours, could I just do less than or equal to 20? I have minutes, and then hours. I'm not going to be able to do that. I can't just do 20 here. What I have to do is I have to convert it to minutes. So I'm going to have 20 times 60, which is going to give me 1,200 minutes. There we go. So there's my first constraint, first inequality. The next one, let's see here, we have reference to pounds of clay. So 1 pound of clay for each plate and 1 for each cup. So that'd be 1C plus 1P. And how many pounds do we have? We've got 250 pounds. So we can use up to 250. Excellent. And then our last ones here, we'll just have our usual cup. We got to be greater than or equal to 0, and our plates have to be greater than or equal to 0. And think about our cups as like our x and plates as our y. I like to use the different letters for variables that correspond to the problem here, but we definitely have to keep them straight and remember which one's which when we're graphing. Okay, well, now we're into the graphing portion of the problem. Let's go ahead and graph it. Now I can use my x and y intercepts to graph these. So with this first one here, when I solve for C, I'm going to cover up 3P. I solve for C, let's see here, 1,200 divided by 6, that would give me 200. So I'm going to have 200 for C. When I solve for P, I'm going to cover up 6C. I have 3P equals 1,200. Remember, we kind of think of this as an equal sign during this part when we're finding our x and y intercepts. So when I cover up 6C, I have 3P equals 1,200. I'm going to divide by 3, and I get 400. So I have 200 and 400. 200 for my x-intercept, 400 for my y. Let's graph it. So there's my inequality, and it's less than or equal to, so I'm going to be shading below. Most of these you'll notice shade below like this. All right. Next one. I have 1C plus 1P is less than or equal to 250. So basically, when I cover it up, when I cover up P, I'm going to have C equals 250. When I cover up C, I'm going to have P equals 250. So both my x and y intercepts are going to be 250 for this one. Let's graph it. And of course, once again, it's less than or equal to, so my arrows go down here. And if I was able to use a straight edge on this, my point of intersection would be right there. Okay? Right at 150, 100. So that's where my point of intersection would be there if I was using a straight edge. I can't use it on here, but you should definitely be using a straight edge. And what do you have that's always a straight edge by you? Your ID, because you're living the Raider way and you're wearing your ID at all times so everybody can see exactly who you are. God, that's excellent. You guys are doing an awesome job. Living the Raider way. All right, the last ones we have C is greater than or equal to 0. That's like my x is greater than or equal to 0, so I have my vertical line. And then lastly, p is greater than or equal to 0. That's like my y is greater than or equal to 0, so it's a horizontal line. And there we go. I've got my feasible region. Let's go ahead and shade that bad boy. You can do those sound effects. It makes it so much fun when we do these problems. Sound effects are awesome. Boom, look at that. Those are some fun colors too. It's like a neon party, you know, but it's a math party, so it's like extra cool. All right, let's get these corner points. I've got one right here. That's 0, 0. I've got one up here. That is at 250, or sorry, 0, 250. I've got one over here. Remember, that one is at 150, 100. And then lastly, this one over here, we've got 200, 0. Excellent. We got all of our corner points. Let's plug them into our objective function. So when I do that, remember we got to plug in 0, 0 in for C and P. Well, if I don't do anything, I ain't going to get no money. When I plug in 0, 250, I end up with 375. When I plug in 150, 100, I'm left with 450. And when I plug in 200, 0, I'm left with 400. So that mixed one right here, the mixed bag of tricks here, 150 cups and 100 plates, is going to allow me to maximize my profits. And the profits I'm going to get are $450. So that mixture of the two is our best bet here, given the constraints that we have, given the amount of clay that we have and the amount of time that we have available to make these cups and plates. 150 cups and 100 plates is going to be our best bet.